Hello and welcome to Session 5 of the 2021 UPRT Safety Summit for Professional Pilots Worldwide. I'm Randy Brooks, and it's my honor for this session to introduce our guest speaker, Captain Bryan Burks of Alaska Airlines. Bryan is going to be speaking with us on integrating simulators into UPRT, practical demonstrations of aerodynamic principles. Captain Burks has been at Alaska Airlines since 1995 and has accumulated over 26,000 flying hours, over 3,000 hours as a simulator instructor, and has served in the past as a check airman at Alaska Airlines. In 2009, Bryan was appointed as the training co-chair of the Royal Aeronautical Society's working group to identify training to mitigate the threat of loss of control in flight, ICATEE, or the International Committee for Aviation Training in Extended Envelopes, and it was my pleasure to be Bryan's co-chair on that effort, where Bryan testified to both the Stick Pusher and Adverse Weather Aviation Rulemaking Committee and the Loss of Control Avoidance and Recovery Training ARC, which met at ICAO headquarters in Montreal. Since 2013, Captain Burks has worked with over 30 different airlines and military organizations worldwide on enhanced UPRT techniques. Bryan has a master's degree in aeronautical science from Embry-Riddle Aeronautical University and is a fellow of the Royal Aeronautical Society. It's my pleasure to introduce today Captain Bryan Burks.
Well, thanks, Randy, and thank you, APS, for hosting another wonderful webinar. I don't think I've missed one yet, and it's such a welcome opportunity to stay engaged in the world of UPRT and the time of COVID. So we're looking forward to making continual progress on UPRT. So my role today is to talk about the role of simulators is as an integrated approach to the solution of UPRT and loss of control in flight. And here's some lessons learned, because we go back to 2012 at Alaska Airlines when we first started what we call enhanced UPRT. And obviously this is 7 years before the FAA required enhanced aero-models or the enhanced instructor tools that are prevalent now in the United States. So here's some takeaways. Really important to understand the limitations of your simulator and making sure you're operating within its validated envelope. And another huge one, unfortunately, we have experience with at Alaska, is to identify and eliminate negative training, which can occur if you use the simulator inappropriately, particularly when you're doing UPRT-specific work. And here's a real emphasis item. You can start good UPRT with current unenhanced simulators. And primarily you're doing that by emphasizing the tremendous capabilities of modern primary flight displays and all the dynamic cues they allow pilots to have to monitor the energy state and the flight path of the aircraft. And when you combine that with an aero model that allows force feedback for the pilots to see and feel the effect of flight control inputs when they're in the UPRT domain, it's a very powerful tool that really builds on academics. So it kind of closes the loop on academics by giving them practical demonstrations of those aerodynamic concepts in the aircraft. And then really important is establishing clear training objectives. Now, mostly what we've used simulators before in the inventory is to practice profiles or procedures or specific required maneuver sets, and then also to do surprise scenario type events involving CRM or their other aspects of training. What we haven't done a whole lot of is use the simulator specifically to demonstrate aerodynamic concepts. They might not be a profile that you fly, they might not be a procedure that you do, but you're using the aero model, the primary flight display, and all those dynamic effects to allow pilots to see the practical demonstration of some of their flight control inputs and in emphasizing the aerodynamic concepts behind that. We find that very, very powerful. And then I'll kind of close with this. We believe that the simulator is the best tool to provide practical examples of these aerodynamic concepts. We are huge proponents of very good ground school for academics. I know Philip Adrian later on will have an excellent presentation on the appropriate use of practical or part task trainers or lower fidelity level device trainers, those certainly help close the loop on this. But when you take all the features of the high fidelity of a full flight simulator and you design clear training objectives that are there to demonstrate aerodynamic concepts that we believe are critical for pilots to understand, that's where you get a lot of gain. So let's go to the next slide. So understanding the limitations of your simulator, I want to give an example of negative transfer training that we discovered. This is back in 2011 when our design team wanted to come up with an upset for 2011. They wanted to do a high altitude upset, and they noticed on the simulator iOS station that they could select a button that would pitch the aircraft up about 20 degrees and then would simultaneously roll it 60 degrees bank at a constant roll rate. And we thought, that's cool. That would be a nice upset event to do that. And our simulator engineers actually built in a visual of a 747 that we were following and a TCAS presentation on the primary flight display. And basically, we're going to fly into a wake. The button would be pushed. The aircraft would pitch up 20 degrees and start a 60-degree constant rate roll-off. Well, what we didn't understand was that in that scenario, it's what's called washout, and that any flight control input that the pilot would make in the recovery from that event would not be honored at all by the simulator. So what we found out is when we introduced this to the pilots, just assessing this as an appropriate maneuver, the aircraft pitches up. Next thing you know, autopilot, auto throttles off as per the procedure, and the pilot would put in initially a gentle flight control input, gentle nose down elevator input, and as it starts rolling off, gentle aileron input because it is high altitude, and it didn't dampen or slow the roll rate or pitch rate at all. So the next thing you know, the pilots are having full aileron input, and the instructor is telling rudder, rudder, rudder. And until it reached that final degree of 60 degrees of bank, it didn't honor any flight control input. So what we created was a scenario that suggested to our pilots that if they ever had a high altitude wake vortex encounter, that they would probably have to use pretty aggressive flight control inputs, which is the exact opposite of what we want our pilots to walk away from. So luckily, we discovered that in 2011. The organization learned a lot about that, and we've been very wary and cautious about how we identify the appropriate training maneuvers we do, certainly when it comes to UPRT. So let's go on to the next slide here. Here was a big opportunity that we kind of lost in retrospect. Alaska Airlines transitioned from old analog-based aircraft. We're talking 737-200s, 727s, MD-80s, to the 737 Classics and later the NGs and the Maxes, which we fly now. So look at the difference. We had the old analog presentation, airspeed and an attitude indicator. And next slide, let's contrast now to a modern display. The primary flight display. It's kind of embarrassing, but when we look back and we made this transition, we never built into our training curricula an emphasis on the tremendous cueing and information that's available to the pilot now in these primary flight displays. Contrast that to the analog instruments. There's so much more information that the pilot can avail themselves of. We have high and low speed limits. We have trends. We have energy state. You even have, in this case, an indirect angle of attack indicator. Now, I'll say now, this is a presentation from 2011. All our aircraft have angle of attack indicators, but if you look at the aircraft reference symbol and the flight path indicator, that spread right there is your indirect angle of attack right there. So contrast the presentation on the left, 15,000 feet, and look at your speed tape. There's no high or low speed limits there. You've got a huge operating envelope. We've got lots of available thrust. Contrast that to the right where you're up there at high altitude with a much narrower envelope there with very limited thrust. And the flight control handling characteristics are going to be much, much different. So in retrospect, we've gone back and really emphasized the importance of pilots understanding and utilizing the tremendous dynamic information from the primary flight display. Let's go to the next slide. And now it's not just the primary flight display. When you have an aero model, you have the ability to have flight control inputs And the aero model was going to give you feedback on the flight control inputs based on the condition of the aircraft. So the aircraft is going to handle a lot differently at normal speeds at a normal environment than it would at a high angle of attack, at a high drag state where you have very limited roll control or degraded roll control, and the difference between high and low altitude maneuvering. So in retrospect, I want to give you an example. This goes back to 2012. We're going to show a video here shortly where the training objective is not a procedure, it's not a profile, it's strictly to demonstrate to the pilots some aerodynamic concepts that we think are very critical for them to understand. And so we're going to show them manual handling at 15,000 feet, and we'll contrast that to high altitude, where the manual handling characteristics are much, much different. They have to be much gentler and proportional in flight control inputs. And why is that important? Well, your memory items for an upset at altitude, your first memory items are autopilot, auto throttles off. And let's put it in context a little bit. Air France 447. All three pilots on that aircraft had never hand flown the A330 at high altitude, nor had they had the opportunity to hand fly the simulator at high altitude. And we feel that that's not a good preparation or a training process for our pilots. So here's a video, just a short example of a practical demonstration that has an aerodynamic lesson involved.
One of the primary objectives we're getting here of manually flying this in the simulator at 35,000 feet is in the event that you had to turn off the autopilot and the auto throttles at altitude due to a wake vortex or an upset, that you can anticipate the light control forces that we have up here due to lack of aerodynamic damping.
Yeah, it's real noticeable.
Perfect. Especially in the pitch. The same pitch moment you put at 15,000 feet will result in twice the amount of pitch excursion due to the lack of damping qualities here. All right, that's very nice, Doug. Now we're actually going to go to 45 degrees of bank, and that's going to very quickly put us in the buffer limit, and we'll start seeing some of the aerodynamic effects here. You'll feel aerodynamic buffet.
Bank angle.
And the airspeed is continuing to degrade. What's your angle of attack approximately now?
8 degrees, 5 degrees.
You see how quickly that happens?
Yeah, it happened fast.
Okay. So just for demonstrations, we'll keep it at 45 degrees of bank, just for demonstration. Look how quickly airspeed bleeds off. We have no available thrust to overcome that. And again, the same thing. If you try to recover as you're holding load on there, your ailerons are going to be much heavier. Okay, now go ahead and just recover by unloading, pushing. Look at your speed tape. And your ailerons, are they more effective now?
Yeah, they are.
All right, demonstration there of controllability.
So again, that's just a short video, and the entire training objective was not a profile or a procedure. It was to demonstrate some aerodynamic concepts. And there's very many of these concepts that we were able to deliver beginning in 2012 up until the FAA mandated the enhanced aero model in 2019. So here's some key lessons or takeaways. Aerodynamics is the absolute baseline for pilot awareness and knowledge of how to operate their aircraft appropriately. And we find that practical demonstrations of these aerodynamic concepts are very powerful. I noticed in an earlier webinar, APS found that about academics alone could provide about a 17% mitigation level. When you combine the simulator, it's about 43%. And the on-aircraft training brings it up to about 76%. I have a hypothesis that if you use the simulator as the primary tool to teach aerodynamic concepts, so you're not just doing profiles that are related to normal flight activity, you're using the simulator to teach aerodynamic concepts, then that efficacy or the transfer of training and knowledge is going to increase even more. That's what we've seen. So instructor competency is critical to this. You have to have very knowledgeable instructors. And we believe that the simulator is the very best tool to provide practical demonstrations of the aerodynamic principles. So let's go to the next slide here. Let's see some data. How are we doing? So since 2012, the next slide, we've been capturing some data. And this is a very elegant data set. It's called a low speed precursor rate. Basically, it's defined as 1.1 times the minimum safe speed. So this is well low into your amber band, just above stick shaker speed. It's not a place a pilot usually finds themselves in their career, but it can happen. And what's neat about this trigger point, this data point, it's collected in all our aircraft. 1.1 is valid whether, regardless of the aircraft type, the configuration of the aircraft, the altitude, or the weight. It's just 1.1. So since 2012 on the left, when we introduced about 30 minutes of focused UPRT, which mostly involves manual handling and training objectives, which are specifically designed to demonstrate aerodynamic concepts, you see a tremendous or a steady decline in the low speed precursor rate. And let's go to the next slide. This is just another demonstration. These are the low speed events per year, per 10,000. So it's per rate. So it's a significant decline. Now I want to demonstrate another subjective takeaway from this. Next slide. One of the events that we've experienced, unfortunately, very often at Alaska Airlines are unreliable airspeed events. We actually had 7 of these in the year 2017. The good news is we've hit unreliable airspeed training heavily on multi-year cycles beginning in 2012. So we've had maneuver-based training where we have an unreliable airspeed on takeoff, and the pilots will literally have to manage that event all the way around a circuit to landing, where they don't get that airspeed back. We've had demos and videos in all phases of flight, and we've had scenario-based training. So we give good maneuver-based training first to build confidence in the pilots that they can recognize and manage the event, but we have to be able to evaluate how they would actually perform in a real-world scenario. So a few years ago, our LOE, our spot loft, was actually an engine event out of DCA, and that's a short runway. That flight is always to the West Coast. It's a very heavy aircraft, and it was an engine event. It could have been an engine failure, fire, severe vibration, but also was due to a bird strike. So we had the engine event followed very shortly by an unreliable airspeed because the birds also took out the pitot-static system. So talk about a compounded event, but even though that was a multi-emergency type of scenario, a very challenging scenario, our pilots were able to manage it effectively. And we think that's because we gave them multi-year cycles of different types of unreliable airspeed events. Next slide. The most critical example of this is we actually had a real bad one up in Cordova, Alaska on an RNAV approach in the weather, IMC, in turbulence, close to the ground in the terrain. Very confusing scenario because we had simultaneous overspeed and stick shaker, and the pilots were able to identify, run the appropriate memory items, recall items, and effectively manage the event. So kudos to adopting UPRT, and that was a good outcome. And I think we're down to our last slide here, Randy. So we're just going to go ahead and open this up to questions and answers with the team. So thank you very much.
Very nice presentation, Bryan. Thank you very much for all of that. And we've got about 10 minutes left, so we're going to have the opportunity to take a couple of questions here from the folks that are watching. If you have any questions that you'd like to get to Bryan before we're done, you go ahead and put them in the chat stream right now. But before we get to those questions, Bryan, I understand there's another event that you'd like to tell everybody about. The folks that are watching this would probably be interested in that one as well.
Well, thanks, Randy. We had planned to host a global UPRT Symposium co-hosted by Alaska Airlines and the Boeing Company in Seattle. That was all scheduled for April of last year. And of course, COVID hit. The first global UPRT Symposium was successfully hosted by United Airlines in Denver, but that was mostly concentrated on U.S. operators because that's right shortly after the enhanced mandate went into effect in the United States with the FAA. Now that we've gained experience of several years of UPRT with all the operators, we're really focusing on global operators where that's not mandated by the national regulator. So as soon as the COVID mess is open or over, we look forward to hosting a global UPRT Symposium in Seattle, and we'll get that information out as soon as we can.
We're holding you to that, Bryan. We know you can't help putting it off, but I will tell you that my ticket had already been purchased to come. So the first question that we have is going to make you put your thinking cap on just a little bit. It's from a friend of ours, Mark Greenfield, who's a UPRT provider himself in the United Kingdom. We worked with Mark on the EASA regulatory working group. Thanks for being on board, Mark. Mark asks, are there any scenarios where there might be value in demonstrating scenarios that are outside of the valid training envelope?
Well, I'll be honest with you, there may be. However, we're governed to conduct all the maneuvers within the validated envelope. The reason being is we want to have confidence that the aircraft or the simulator is replicating the behavior of the actual aircraft. That's the whole intent of having a validated envelope. So if the pilot possibly puts in extreme flight control inputs and the aircraft goes out of the validated envelope, the instructor would be incumbent to redo that maneuver, explain to them, hey, we got well outside the envelope. What you felt and saw with the aircraft or the simulator might not represent the actual behavior. So let's go ahead and repeat that scenario to ensure that you're getting a realistic representation of the maneuver. Now, that's not to say that there might be some value in going outside of that, but that's not the mandate. We know from UPRT, you need to be as standardized as possible. And so I guess I would say that the consequence of doing it wrongly in the UPRT realm is more significant than other areas of airline training. So you want to be very careful about that.
I think that's what we'd call a slippery slope, right, Brian?
Yes.
So let me just ask a related question before we go to the next one from the audience. Here in the United States, we have enhanced aero models that allow us to go to places that we would never want pilots to go, and that would be beyond critical angle of attack. Can you talk to the audience a little bit about the care that you need to take when you're demonstrating something like the stall characteristics of the 737?
Well, our experience is, starting in 2012, well before there was enhanced aero models. So it's important that, the primary concern is the instructor knowledge and capability. I know that Brad Bennett is going to speak to that on the last presentation today, so I don't want to steal the thunder on that. But it's just critical that you understand a clear training objective, that the medium that you're using to impart the maneuver, the full flight simulator, they're operating within the validated envelope, that you're able to capture all the flight control inputs that might have been erroneously input, the POTS not even knowing that they inappropriately put in a wrong flight control input. So there's a lot of instructor training required. Now, what I will say is when we started in 2012, it was kind of a blessing. I saw an opportunity to put in a lot more content than what we had available to us. Recurrent training footprints, it's so packed up with required maneuver sets. All we were able to do was 30 minutes. And in retrospect, that was a blessing, Randy, because when we did 30 minutes, we just did that video, manual handling characteristics, contrasted at 15,000 feet with high altitude. And again, we're presenting aerodynamic principles that we hadn't done before. And so when you narrow the maneuver set and you narrow the training objective, it's easier to train the instructors and to standardize them because you're doing a much narrower realm of the UPRT. As we added on subsequent events following 2012, it got more complex and complicated. And certainly by the time you get to full aerodynamic stall, there's a lot more training requirements, a lot more repetitions that the instructors have to gain experience and knowledge in.
And I'll say, Brian, that even when we're using the aircraft, which obviously we don't have to worry about a validated training envelope, we still need to make sure that pilots understand when we're taking them to a sustained stall that we're going someplace that we would never want them to be in real life, but that there are educational benefits of things that we can demonstrate that make it worth doing so. So our friend Julian Castro from down in South America is watching today, and you had a nice segue to Julian's question. He says, how do you assure instructional quality in UPRT instructors, and how often do you recheck that to see how they are doing, standardization and inter-rater reliability?
It is a huge focus. So we have a core team of UPRT developers that are responsible for the standardization throughout the instructor group for that. And we have had a formal IRR or inter-rater reliability program for years. So basically we'll present a scenario, usually a video, and we'll have the instructors in the room assess the performance. We're hoping that we'll get a standardized reflection of the event from the instructors present. And if there are errors, we'll have to go back and check that. But I'll say that I think an organization can always do better on emphasizing the training requirements for instructors. And Randy, I have one correction for my presentation. When I said that we felt at Alaska Airlines that full flight simulators were the very best tool for training UPRT, I was talking about devices, because I'm a huge proponent of on-aircraft training. But so I want to qualify that. The best training device to teach UPRT are full flight simulators, where you have the fidelity of the primary flight displays and the force feedback from the aero model, and the pilots can see dynamically the effects of their inputs. So just want to make that clear.
I think there's a question that you're going to be able to, that might address that. But related to what we've been talking about, Roberto says, "Hi, Captain Burks, how often does Alaska Airlines train their pilots on the aerodynamic principles that you were talking about today?"
Every year. We're under AQP. Our cycle is a 3-day cycle every year. So at least once during the year, we have 4 quarterly training segments of academics, which are just under 3 hours each. So 12 hours for the year. We'll always have a UPRT or aerodynamics academics. And then we specifically designed in and required by the new FAA mandates to do a certain, it's all adopted in the mandate, what we're required to do. Some are yearly, some are bi-yearly, but we comply with that and we actually exceed those standards. But what I'm guessing is going to happen, and if I had to put my hat on in 5 or 10 years, UPRT and aerodynamic principles are embedded in everything we do as a pilot. So right now it's somewhat new to industry, but my hope is that in 5 or 10 years, it'll be so embedded as a natural part of the courseware and the curricula that it's just part of the entire integrated suite of content. And one thing more I want to say is one huge opportunity that every airline pilot has, and hopefully their management team will support this, is to fly the jet manually as much as possible. The simulators are great, but if you do a lot of manual flying or as much as possible out on the line, your skill sets are going to go up. Your ability to look at the primary flight display and understand your energy state and your flight path. And we emphasize that quite a bit at Alaska, and quite often we turn the flight directors off. In fact, we are even considering having the pilot not flying operate with the flight director off at all times, so they get more integrated into monitoring the energy state and flight path of the aircraft through the primary flight display. So again, fly the jet, fly the jet, fly the jet.
Glad you were able to get that in there. I think we've got time for 2 quick questions. One goes a little bit to the airplane aspects. It's a little bit long. He says, we don't have G in the aircraft. This is from Victor Lemmy. How to train them after a pitch down upset to manage the high speed, reducing at the same time, staying below the maximum G load. So how do you impart that and let folks know that it's going to feel a lot different in real life?
Well, you're not going to get the G in the simulator. And this is one of the more problematic areas, because the primary flight display will not give you G loads on a nose low recovery. But what we have found, and you know this, Randy, is a normal rotation rate that a pilot uses for takeoff or a go around is going to keep you under the G limit. So there'll be times in a maneuver where your nose is so far down that even if you turn the autopilot, all throttles off, pull the full speed brakes, your thrust is at idle, and you're managing that energy state, you would rather overspeed the aircraft than over G the aircraft, okay? And again, you're not going to get the G in the simulator, but you will have a G monitor in the back, an enhanced iOS station, so the instructor can monitor your G loads and say that, yeah, we did overspeed by 20 knots, but we stayed underneath, we stayed under the G limits, the structural capability of the aircraft. So that's a common takeaway. Another example is before the FAA mandated this, when you talked about aerodynamic stall, like 10, 15 years ago, you'd ask 10 different check airmen, if I had an aerodynamic stall, what's my pitch target rate? I mean, where am I targeting my pitch attitude? Is it wings level on the horizon? Is it 10 degrees nose down? Is it 15? And you probably get, Randy, 10 different answers. There was no good guidance until ICATEE and others looked into it and found out, well, you got a primary flight display. That'll tell you right there when you're above minimum safe speed and some margin to, to manage any flight control sensitivity in the recovery. It's just a short example.
Well, Bryan, we're missing some good questions. Skip Johnson, I saw you in an earlier seminar, but I'm afraid we've got to go so that folks can get on to the next one. And before we do, I just want to let people know how to do that. They have to go back to the LinkedIn homepage, refresh, and it'll bring up the next event. I just want to say thank you very much, Bryan, for being with us. And we hope everybody will take advantage of that event that you'll be putting on sooner or later.